So back on page 11, we are going to do lesson 9.7 today. And on 9.7, we're going to be talking about the volume of these different right prisms. So just to kind of refresh, what we did in the previous lesson was to go through here. We figured out what shape the base was, and then we found the area and the perimeter of the base. If you actually look down at the very bottom of your page, on page number 11, you can see down at the bottom the picture of the polygonal prism, which is also located on your formula sheet. For today, we're going to be focusing in on the volume formula. So underneath example number 1, I'm going to ask you to write out the volume formula, which is capital V is equal to capital B times little w. So we're going to have to go through and identify two things. B represents the area of the base. So we've actually done that as one of our steps here, but you're going to notice that when we did it, we called it A. So we're just going to cross that off today and call it capital B. So when we go to find our volume, we're going to plug in our number that we found as the area of our base. So for example 1, that was 54, and we're going to multiply it by W. And if you look on the picture at the bottom of your sheet there, that W is actually the length of the rectangle that connects the two bases together. So if I have my base up front here and my other base in the back here, this length of this rectangle is what's connecting them together. So this 6 right here is going to be my W. So that is the what connects the two bases. That's kind of how I remember that one. For most of us, we would typically call this a height of the actual prism, but they tend in the PSSA formula sheet to use that W. So I say what is connecting my two bases. So for us, the W is 6. So when we're down here, we're going to have volume is equal to 54 times 6. And the volume then of this particular triangular prism is just going to be 324. And we are going to put our units here because volume is our final answer. And don't forget that volume gets that cubed because we are talking about the length times the width times the height, or that three-dimensional space that the object is taking up. So what this volume formula does is it takes the area of the base and it kind of breaks it into almost like, if you think about this as like a slice of bread. So it basically says, okay, you have one triangle piece that's right here, and that's going to be an inch thick. And oops, my pen is not cooperating here. This is not going to work. Let me try and do this with the mouse instead. Holy cow. Oh, I love technology. All right. Yep, it's still not working. Smartboard is not responding to me here, which is what making this a little bit more awkward. All right, there we go. So now I can actually move this around here. So we're taking this and it's kind of like slicing it into 6 different slices. And what you're doing then with those 6 different slices is finding the area and multiplying it by that 1 inch thickness. And then you're just doing that 6 times because the thickness of your prism is actually that 6 inches then. So it's kind of like if you thought about 6 slices of bread all together, you're kind of taking the area of just one of those slices of bread and then multiplying that 6 times over. So that it actually creates that third dimension for you there. So we're going to go ahead and do the same thing over here for our circle. So for our volume, our formula, oops, and now it's still writing as a line. Okay, that's great. All right, let's try. There we go. Okay, we're good. Oh my goodness. Love technology. So our volume formula, again, is going to be that B times W. B representing the area of the base, which we found up here is A. So we're just going to cross this off and call it B. And then my circle is up top, my circle is on the bottom. So the what connects them together is this 16 part right here. And I am going to ask you to label that on your picture. So your volume is equal to B, which is 314, times your W value, which in this case is 16. So 314 times 16 is going to give you 5,024. And we do have yards and cubed because we are talking about volume. In example number 3 and 4, we had our parallelogram as our base. So again, remember we said this is the area. We're going to cross it off and call it capital B. So I have a parallelogram here on the front, a parallelogram here on the back. What's connecting them together is that 7 inches. So for this one, my volume is equal to capital B times W. My B value is 192. That was the area of the parallelogram. And I'm going to multiply by 7, which is that W value that I have. And 192 times 7 is going to give me 1,344 cubic inches then. For the trapezoidal prism, we're going to again do V equals BW. This area is actually my capital B now. It's the area of the base. So we're going to say that's 28. I have a trapezoid here along the front, a trapezoid here along the back, and what's connecting them together is that 6 that's right there. That's the length of that rectangle. So I'm going to call the W value to be my 6. So 28 times 6 is going to give me 168 cubic centimeters then. So that's how you go and you calculate volume for any sort of right prism. You would find the area of the base, and then you're going to multiply it by the length of the rectangle that actually joins the two bases together.